Hello friends, so in this video we're going to be studying radical equations, right? How true, very true. Now a radical equation would be an equation in the form roots x squared minus 39 minus 19 equal to 0. This would be a classic example of a radical equation. Now how do we solve questions in this form? The first step is to isolate the radical part of your equation. So this would be our radical parts, the parts containing our roots. We isolate it now on one side of the equation, right? So we have to move minus 19 over the equation sign. So we have roots x squared minus 39, moving 19, which has a negative sign, over the equation sign is going to become positive 19. So we have just 19. Before it was minus 19, now it has a positive sign, and that makes it positive 19. Now in doing this, now the next step is to take the square of both sides, right, to eliminate our roots. So this, we have the square here and the square of 19. So it turns out that this square cancels this square root, right? And what we are left with to be s squared minus 39 equal to the square of 19 gives us 361, right? How true. Now when we attempt to find our x, now the test step is for us to find our x. So in doing that, now we're going to have x squared. We have to move negative 39 over the equation sign, right? So this gives us 361 minus 39 here, moving it over the equation sign becomes positive 39. So this gives us plus 39. How true, very true. Now in the aftermath, right, we have x squared equal to 361 plus 39 gives us 400. 400. How true, very true. So to find x, we take the root of both sides, right? Take the square root of both sides. So we have that our x would be equal to the root of 400 gives us 20. So this would be the value of our x. How true, very true. Now the next step is to check if the value we got for our x satisfies the original equation. So our original equation was this: the root of x squared minus 39 minus 19 equal to 0. Let's see if it satisfies our original equation, such that wherever we see x in that equation, we substitute 20. So this gives us the roots now. The roots of 20 squared minus 39 minus 19 equal to 0. So this is what we have, right? We are substituting x into our original equation. So what we have here would be the root now of 400, because the square of 20 gives us 400, right? Minus 39 minus 19 equal to 0. How true, very true. So in the aftermath, right? In the aftermath, what we're going to have would be the root now. The root 400 minus 39 gives us 361. So minus 19 equal to 0, right? How true. The root of 361 gives us 19. So we have 19 minus 19, and this would give us 0. So in the aftermath, right, it satisfies our original equation. How true. Here is another radical equation we could be told to evaluate, right? How true. Now in doing this, now the same rules apply, right? So the first step we said was to isolate our radical. These parts containing a radical equation, we have to isolate it, right? So we leave it on one side of the equation sign. So what we have would be the root of x plus 5. How true, x plus 5. Now on this other side, we're going to have 7. We move x now over the equation sign. It's going to be minus x. How true. Now, in doing this now, the next step we said would be to square both sides. So we take the square here and we also take the square here. How true. So what we are going to have there would be that this square here cancels out this square root, right? And in the aftermath, right, on this side we have x plus 5. Very true, very true. Now on this side of the equation now, we have 7 minus x. The square of this becomes 7 minus x into 7 minus x. So this is what we have on this side, right? So we open up that bracket there. X plus 5 would be equal to 7 times 7 gives us 49. You know how we do it now. So this multiplies this, and it also goes on to multiply this. So we FOIL out right there. So 7 times 7 gives us 49, and 7 times negative x gives us minus 7x. How true. Also, let me erase this. The same rule apply, right, for the other part of the equation now. What we have is this: negative x multiplies 7, and negative x also multiplies minus x, right? So what happens now would be this. We're going to have minus x multiplied by 7 gives us minus 7x. Minus 7x minus x multiplied by minus x gives us positive x squared. How true. Very true. So in the aftermath, right, in the aftermath we have equal to 49 minus, now minus 7x minus 7x gives us minus 14x. How true. Minus 14x plus x squared. How true. Very true, very true. Now we rearrange the equation on the right hand side, right? So we still have x plus 5 here, x plus 5 equal to, now notice now that this is a quadratic equation, right? On the right hand side there, we have a quadratic equation. So we rearrange and we have x squared coming first, minus 14x plus 49. How true. Very true, very true. So we'll move both x and positive 5 over the equation sign now. We will move x over the equation sign, and we move 5, positive 5 now, over the equation sign. Now let's move that. We are left with 0 here, equal to, I rewrite my equation, x squared minus 14x plus 49. Now moving x now over the equation sign becomes minus x, and moving plus 5 over the equation sign becomes minus 5. How true. Minus 5. Now in doing this now, we're left with 0 equal to, now we attempt to collect like terms, right? So we have x squared, we put the variables containing x to minus 14, x minus x plus 49 minus 5. So we have been able to collect like terms, right? How true. Very true. Moving the page, we have 0 equal to x squared. Now minus 14x minus x gives us minus 15x. Minus 15x. 49 minus 5 gives us 44 plus 44. How true. 44. Now what we are left with now is a quadratic equation now. So we can choose to factorize this quadratic equation now, right? Notice now that we can rewrite this equation as x squared minus 15x plus 44 equal to 0 is the same thing, right? Very true, very true. Now factorizing this now, you know the drill, right? We look for two numbers whose product now gives us 44 and whose sum or difference gives us. So these two numbers are minus 11 and minus 4. What this gives us is minus 11 minus 4 gives us our minus 15. Also minus 11 times minus 4 gives us our positive positive 4. So the two factors there, the two numbers there are minus 11 and minus 4. So we factorize now. We have x squared minus 11x minus 4x plus 44. How true. So we can do this now by enclosing this part of the equation in a bracket and enclosing this part of the equation in another bracket, right? So for this first bracket now, what can we factorize out of that bracket? We can only factorize x out of that bracket. So we have x into x minus 11, right? How true. From this second bracket now, we can factorize minus 4 out of this bracket, and we are left with x minus 11. How true. Equal to 0. So in the aftermath, right, we put this variable and this variable together, right, and we have x minus 4 in one bracket, and we also have x minus 11 in another bracket, right? How true. Equal to 0. So this gives us x minus 4 equal to 0, or x minus 11 equal to 0, right? So what we have now would be x equal to 4 or x equal to 11. So we move them over the equation sign, and the minus 4 became positive 4 and the minus 11 became positive 11. Now this would be our answer, but we have to check the validity of our answer, right? So we have to put that value into our original equation now. So notice now that our original equation was x plus 5. This was our original equation now. The root now of x plus 5 plus x equal to 7. So we're going to put each of these values we got for our x into this equation and see which of them satisfies our equation and would give us 7 in the aftermath, right? So for x now, x equal to 4 now, we put the value of x as 4 in this equation now, and we have the root of 4 plus 5 plus 4, right? So let's see if we solve this, it's going to give us 7, right? So when we do this now, this gives us 4 plus 5 gives us 9. So the root of 9 we have here, right? We have the root of 9 here, plus 4. Now we solve again, and this gives us the root of 9 gives us 3 plus 4, and in the aftermath this gives us 7. So it turns out that x equal to 4 is one of the valid roots of this equation, right? So let's try out x equal to 11 if this is one of the valid roots of the equation. So also we have that x equal to 11 now was one of the answer we got, right? 11. So we have the roots now, the roots of, we are going to put the value now 11 into our original equation, right? Into this original equation. So we're going to have 11 plus 5. This is plus 5. So in evaluating this now, this gives us 11 plus 5 now gives us 16. So we have the root of 16 plus 11. Let's see if we evaluate this, if the answer we get would be 7 according to our original equation here. So this gives us the root of 16 plus 11. So in the aftermath now, we have the root of 16 gives us 4 plus 11, and this gives us 15. How true. Very true. So it turns out now that only x equal to 4 is the valid root of our equation. This is the only value that satisfies our equation. So since only x equals to 4 satisfies our equation, then our final answer becomes x equal to 4. How true. This would be our answer, since x equal to 11 does not satisfy our original equation. That's my time, guys. Thank you so much for watching. See you in the next video.